Welcome to today's tutorial. And in our tutorial today, we're going to look at this question that's shown on the screen. This question has got two parts. It has got a question that's coming from algebra, and then another question that's coming from sequences, to be specific, geometric progression. So we will start with the A part there, where we are told to simplify uh, y plus 1 over y squared minus 1. So the best way of solving the A part of this question is that we need to factorize the top part. We also have to factorize the bottom part. So if you look at the top part there, where we have got y plus 1, okay, we have to check first of all if there is a common factor. Now, knowing that there is no common factor, so we assume that the common factor there is what? Is 1. And I'm going to have y plus 1 here over. And this one, since there is no common factor, and as we can see there, that the y is a square, then 1 also, it happens to be a perfect square. That means that this expression can be written as y squared minus 1 squared. Now take note, whenever an expression is written as this, okay, that means it can be factorized in this manner, meaning we're going to say a minus b, you close the bracket, then a plus b, you close the bracket. So meaning this y squared minus 1 squared, which is in this form, it's going to be expressed as open bracket, then y minus 1, then you close the bracket, then again you open the bracket. It's going to be y plus 1, then you close the bracket. So therefore we shall say 1 there, 1 plus 1, you close and over, then y minus 1, okay, then y plus 1 also. So if you look at this, you look at those that are similar. So we have the y plus 1 and the y plus 1, meaning you cancel those. That means you are going to remain with 1 over y minus 1 as the answer for question A. Okay. Therefore, you even get 2 marks for that question. Now we continue. Go to the one that deals with geometric progression. Now the question reads, the sum of n terms of a geometric progression is given by 10 minus 10 over 2 to the power n. Now find the sum of the first 4 terms of this geometric progression. So here they want us to find the sum, okay, of the first 4 terms of the geometric progression. So how do we find the sum in this case? Knowing that n will be equal to 4, because we've been told that the sum of the first 4 terms. So we've been given the formula already. So what do? Shall say that b Roman numeral 1 shall say sum is equal to 10 minus 10 over 2 to the power n. So in this case, we shall say where n is equal to 4. So here we are saying that the sum of the first 4 terms is going to be equal to 10 minus 10 over 2 to the power 4. So sum of the first 4 terms is going to be equal to 10 minus 10 over, now 2 to the power 4, it does not necessarily mean 2 times 4. It's basically telling us that it is 2 times 2 times 2 times 2. You multiply these 2 4 times and it's going to give us 16 there. So we can say that sum is equal to 10 there minus, can cancel out there, 2 there, that's 5, 2 there, we have the 8. So we can say that the common factor here, okay, for 1 and 8 is going to be equal to 8. So the 8 happens to be the lowest common multiple, where 1 and 8 can go minus, leaving a remainder. So 1 into 8, it is 8 multiplied by the 10 there. That's going to give us 80. Then 1 into 8 into 8, that is 1. 1 multiplied by 5, that's 5. So therefore, we're going to say that sum of the first 4 terms, it's going to be 80 minus 5. That's going to be 75 over 8. Okay? So, or if you want, you can be able to express them into a mixed fraction, or you can leave your answer, okay, as a decimal, okay, which is going to be equal to 9.375. Okay, so that's the sum of the first 4 terms of a geometric progression. Okay, we continue. Next question, they are saying the first term. Okay, now I want you to take note of something. Since we have been given the formula there for the sum, okay, so take note that the sum of the first term, okay, is equal to the first term, because the term is just alone. Okay, so that number itself is going to be the sum of the first term. So therefore, if we are to use this same formula, where there is n there, just have to substitute with what? With 1. So we shall say sum of the first term is equal to 10 minus 10 there, and 2 to the power 1. Sum of the first term is going to be equal to 10 minus 10 there divided by 2. So therefore we shall say 10 minus 10 divided by 2, the answer is 5. And 10 minus 5, we're going to get a 5 there. So therefore we can say that sum of the first term is equal to the first term itself, which happens to be a 5 in this case. Okay. We continue. We look at the next question. The first 4 terms. Okay. Now when we say the first 4 terms, we have the first term already, but we need to find the second term. Okay. So I want you to follow me very well. So since the first term we have already, which we said the sum of the first term is equal to the first term itself, and that happens to be a 5. So the best way to find the second term is for us to find the sum of the first 2 terms. Sum of the first 2 terms, then we're going to subtract the first term so that we remain with a second term. Okay? What I mean is, if your first term is 2 and your second term we don't have, but the sum of the first 2 terms is 6, it becomes easier for us to know the second term, because we are just going to say first term plus second term is going to give us the sum of the first 2 terms. So this is what we're going to do. So sum of the first two terms is equal to a 10 there minus, we have 10 there divided by 2 to the power 2. So sum of the first two terms, we're going to say 10 minus 10 divided by 4, which is 2 to the power 2 there. So we can say sum is equals to 10. Now, 10 divided by 4, the answer there, it is 2.5. Therefore, the sum there of the first two terms, 10 minus 2.5, we're going to get 7.5. So this happens to be the sum of the first two terms. Now I want you to follow me very well. Since it is sum, that means we're adding. So, meaning, if we are to add the first term plus the second term, it's going to give us a sum of the first two terms, of which the first term we know already to be 5, second term we don't know, and the sum, it happens to be 7.5. So when the 5 crosses the equal sign, we shall say second term is equals to sum minus 5 there. So therefore, the second term, we can say it is 2.5. Okay? So now that we have found the second term, we can say, therefore, it will be very easy for us to come up with what we call as the common ratio, which we're saying common ratio is equal to T2 divided by T1. Our T2 being 2.5, our T1 being 5, 2.5 there, it is 1, 2.5 there, we're going to say 2. So that means this is our common ratio. So now that you have your common ratio, we can find the remaining terms. We have the first term, which is a 5. We have the second term, which is a 2.5. Therefore, let's go to third term. So we say T3, remember, we are told there that's going to be a r to the power 2. So this 2 is found by subtracting 3 minus 1. Okay, so if it's like that, our first term being 5, and our common ratio being 1 over 2, that is to the power 2. So we shall say this is going to be 5, 1 to the power 2, that is 1, and 2 to the power 2, that is 4. So this is going to be 5 multiplied by 1, it's going to be 5, then over 4, meaning this is the third term. Okay, do the same for the fourth term. We shall say 4 to the power, fourth term there, it's going to be a r to the power 3. First term, it being 5, and 1 over 2, okay, squared there, so to the power 3. So we write your 5 there. 1 to the power 3, it is 1. 2 to the power 3, it is 8. Okay, so 5 multiplied by 1, it is 5 over 8. So therefore, we can say the first 4 terms, okay, over GP are number 1 to be 5, number 2 to be 2.5, number 3 got 5 over 4, and the last one we have got 5 over 8. Okay, as simple as it is, this question was carrying 3 marks there. And the other one, this one was carrying 2 marks. Okay, so for questions, you can text us and we'll be able to see how best we can be able to help you. We'll meet next time as we'll be looking at another question. Bye-bye and enjoy your studies.